Hello friends, welcome to G-Centric. So in this lecture we will continue with the problems, and our first problem is the 11th problem, continuation of the previous lecture. So this question, it was asked in GATE 2014 electrical branch. So they have asked to calculate the value of XL. So now the total power dissipated in the circuit shown in this whole circuit, okay, it is 1 kilowatts. So the voltmeter across the load reads 200 volt. So this is the load XL plus R, and this is the voltmeter that is connected across this load. So that reading is 200 volts, and they have asked to calculate the value of XL. Okay, so we have to find the value of this XL. So to proceed for that, okay, so just see whatever has given in the circuit. So now we have got AC source, we have 10 ampere of current flowing in the circuit. Okay, 2 ampere goes here to the 1 ohm and XC1 and XC2, but in this branch we don't know the current. Okay, and if we know the current also, we don't know the values of XC2 and XC1. Okay, so this 10 ampere current is going to 2 ampere in this branch, but we do not know how much ampere of current is going in this branch. We cannot directly apply the KCL over this node. Okay, that is because we do not know what is the angle. So now, but we know the concept that if we, okay, so let me take this one, if we make the current to enter 10 ampere, then from the circuit also it has to leave the 10 ampere of current. Okay, so now when it is going 10 ampere of current, okay, but here coming to this part, this is the voltmeter, it is not the voltage source, but it is the measuring device of the volt. So we know that here 0 ampere current flows. That is because the voltmeter has got infinite resistance. Okay, so when infinite resistance is there, the current flows the path of the least resistive. So what happens? This 10 ampere current flows in this circuit. Okay, so here it is 0 ampere, it becomes 0 ampere, okay, it becomes open network. Okay, so that is why there will be no current flowing in this branch. Now 10 ampere of current flows in this branch. Now they have said that power dissipated in the circuit. So which element dissipates the power? That is the resistor. Okay, wherever there is resistor, only that element will dissipate the heat or the power. Okay, that is the loss. Now for this XC1 and XL or XC2, there will be no heat dissipation. Okay, they are the storing elements. So what we can write is that, okay, power is given, so which will be equal to that is total power in the circuit. What it is? 1 kilowatt. Okay, so this is 1 kilowatt, so I will write it as 1000 watts, okay, which will be equal to total heat dissipated by this element 1 ohm and by this R. For this R, we do not know what is the voltage, okay, we do not know what is the current, and we do not know what is the resistor value also. Okay, so we will just calculate for this one, that is I square into R, that is 2 square 4 into 1. 4 plus this one, we will do it for that equation. Okay, but we know what is the current flowing in the branch, that is 10 square. Okay, we will keep 10 square into R. Okay, but now we have got all the values, 1000 watts, 4, 10 square and R. So we can calculate the value of R. So R will be equal to, this is 1000 minus 4, 996, okay, divided by 100, so 9.96 ohms. Okay, so this is the value of that resistor. Now if I redraw that circuit, the second circuit, we have inductor and resistor. Okay, this is XL and R, and what is the voltmeter reading across this one? 200 volts, and current is 10 ampere. And we know the value of resistor, 9.96 ohms. We have to find the value of XL, but we know the phasor relation between these two. We have got 200 volt. If we find the voltage across this one and voltage drop across this one, okay, so we can find what is the XL. Okay, for resistor, the current and the voltage, they are in phase. With respect to current, current will lag in the inductor circuit, but voltage will be leading. So if this is VR, this is VL, and this is total voltage in the circuit. So what is the total voltage that we know? That is 200. So this will become 200. Okay. So this VR, how much is this VR? How we can calculate? We know this 10 ampere current is flowing in the branch, we know the resistor. So voltage drop across this one will be 10 into 9.96. That comes out to be 99.6 volt. Okay. We only don't know VL. So using Pythagoras theorem, we can solve the value of this as 200 square minus 99.6 whole square. Okay, so the answer for this one is 173.43 volts. So now we know what is the voltage across this VL. Now how do you calculate XL? Okay, so this XL, it can be calculated, it is nothing but what? Ohmic value. So it is voltage upon current. Okay, so current we know 10 ampere, voltage also we know, we have found it here, 173.43 divided by what is the current? 10 ampere. So which comes out to be 17.3 ohms. Okay, so the value of XL is 17.3. Okay, so this is how we will solve this problem. Okay, so first whatever it is there, how much current will enter, that much amount of current will leave the circuit. Okay, so when this is the voltmeter, okay, it's not a source, so it's a voltmeter measuring device, it will have infinite resistance. Okay, so that is the reason we have got 0 ampere which will become open circuit, whatever current is flowing here will flow through this branch also. Okay, so through this we know they have given already the power for what is the total power dissipated in the circuit and what is the only heat dissipating element, that is the resistor. Okay, so this resistor will dissipate the heat, and that is why we have taken the total power dissipation only for the resistive elements, and the capacitor and the inductor are the storing elements. Okay, so next we will come to this problem. Okay, so I'll rub this full part, okay, so that we will solve this one. Okay, coming to this 12th problem. So the question is, of 159.23 microfarad capacitor is connected across the resistor in parallel with R ohm. Okay, and this circuit draws a current of 25 amperes from 300 volt 50 hertz supply. Okay, so we have to find the frequency at which the circuit draws same amount of current from 360 volts. So what they have said is that, okay, there is a capacitor connected in parallel with the resistor of 25 amperes which is drawn from the 300 volt source with 50 hertz frequency. This same circuit is there, but they have changed the value of this voltage source, that is 360 volts. Okay, and we have to find the frequency of what is the 360 volts source. So now we will first draw the circuit of the first statement. Okay, so they have said we have the capacitor and a resistor connected in parallel. Okay, so this value is 159.23 microfarad, which is connected to a voltage source of 300 volt 50 hertz, and it will be giving out 25 ampere of current. Now there is a same circuit, okay, here we will draw it here, which has got 360 volt. Okay, but we have to find the frequency of this one. Okay, the capacitor value remains same. We don't know what is the resistor value, we have to find it. Okay, so this capacitor is 159.23 microfarad with the same amount of current. Okay, so we have to find this frequency. Where the capacitor value remains same, this Xc value gets changed, okay, because of this change in the supply voltage. Now to find the value of this R, so to find the value of this R, we should know what is the current in IC, okay, in the capacitor as well as R. We know that 300 volt will appear across both of the elements. Okay, so to find that, first we have to convert this into ohmic value. So that is Xc. Okay, so let us take this Xc1 as for the first circuit. So this will become minus J upon omega C. Basically this J will be down, okay, J omega C, if it goes up, it will be minus J omega C. So this is minus J 2 into pi into, okay, so this omega is nothing but 2 pi f. Okay, so here the frequency we know in the first circuit, that is they have given as 50 hertz, and the value of capacitor 159.23 microfarad. Okay, so this is the value, and how much you will get is minus, the value of this one will be minus 20 J. Okay, so the Xc capacitor has got the value of minus 20 J. Now you can find the current across this one. How do you find it? It is nothing but for the finding the magnitude of this one. So I will be V upon R. So V upon R, in the sense here we have V upon Xc, Xc1, which is 300 minus 20 J. So this will comes out to be 15 J. Okay, sorry, it's 15 amperes because we are taking only the magnitude. Okay, so this is the magnitude. Okay, when we are considering magnitude, we will not consider what is with the negative or the imaginary terms. So 15 amperes of current we have got here. Now to calculate the value of IR, we can directly do it with the help of this one, is taking the square root, 25 square minus 15 square. Okay, so it comes out to be 625 minus 25. So the value of IR will be 20 amperes. This much amount of current will flow in 20 amps. Okay, now you know what is the voltage across this one. Here it is plus minus 300 volt. Okay, so this R, it can be calculated as R is equal to V upon I. So here also we will get 15 amperes of current, sorry 15 ohms, 15 ohms. Okay, so this is the value of R. So here the value of R and here the value of R both will be same. Okay, so 15 ohms. Now we know the 15 ohms. Okay, we know this one. We will rub the circuit. The work of this circuit was to find how much amount of resistance we have got in the circuit. Okay, so if I rub this whole thing, okay, I will rub this one. Okay, I will draw this circuit up, or let it be like this. Okay, I will rub this one. Okay, so now we have got 25 ampere here. We know the value of R. We don't know what is IC. We don't know what is IR. Okay, but we know what is the voltage across each of the elements, 360 volt and 360 volt. Okay, so here also 360 and 360 volts. So now once we know what is Xc, okay, 1 upon J omega C, right, we know what is the capacitor value. We have to find the value of Xc. Once we find the value of Xc, we can substitute both of them and we can replace this omega with 2 pi f, okay, and then we can find the value of this frequency. Okay, so now for that we have to again calculate the value of IC and IR. Okay, So what will be IC equal to? VC upon XC. So we do not know what is XC, but we know what is VC, that is 360 volt, and this will be, so we will transfer it here, XC, and this will become IC. Okay, so this is I into C. Now we know 360 volt is here, okay, so this is 360. So this volt we know, and we know what is the value of resistor. So we can immediately calculate what is the value of IR. So what is the value of IR? It is 360 upon 15. Okay. So 15 ones are, okay, it will come in this one 5, 3 5s are 3 ones are 120. So 5 ones are 5 2s are 24. So current here is 24 ampere. So we can find IC from this one. Okay, so what is IC? So again your square root of 25 square minus 24 square. Okay, so this comes out to be, the value of this is 7 amperes. Okay, so when you solve it, 625 minus the square root of this 24. Okay, so when you solve this, you will get the answer as 7 amperes. So now we got IC value, substitute in this equation. So what we will get XC as 360 upon 7 amperes. Okay, so we know XC now. So if when we know XC, we can put it in this formula. Okay, so XC will be equal to 1 upon J into 2 into pi into F. We don't know, we know what is the value of C, that is 159.23 into 10 to the power minus 6, okay, microfarad. So we know the value of XC also, 360 divided by 7. This is not amperes, this is in ohmic value. Okay, so now if you solve this one, you will get the frequency as equal to 19.43 hertz. Okay, use the virtual calculate the, divide it by 1 divided by this value. Okay, so here send the frequency over here, then cross multiply, you will get the value of this one as 19.43 hertz. So what is the value of frequency? 19.43 hertz when the supply voltage is 360 volts. Okay, so when it was 300, it is 50. So the only value that changes is the frequency. The value of capacitor here and the value of capacitor in the first circuit will remain same. It is similar case with the resistor also. Due to the change in the supply voltage, there will be change in the supply and the reactance values. Okay, so we will take one more problem based on this concept. Okay, coming to this problem, that is the 13th. This we have to find I1 and I2. So here is I1, here is I2. Okay, so whenever the circuit is given, check if they are in the ohmic values. Okay, they should not be in Henry and Farad calculation. So now they are in the Henry and Farad values. So we will convert them into ohmic values. So before that, how do you solve this problem? Okay, so basically we can solve this by nodal analysis. Okay, so now if I take this as one node and here this as reference node. Okay, so this is the node V. Okay, I will call it as V. Now here what will be the voltage? It is 24 angle 0 degree. Okay, so now this is the reference nodes. First we will convert them to ohmic value. So XL you have j omega L, which comes out to be j into 2 into 1. So it is 2j. Okay, so this one XC, it is minus j upon omega C. So minus j omega is 2. Okay, 2 is here they have given. Then this will be 1 upon 2. So this is minus j. So this will replace it with 2j and this with minus j. So we know the ohmic values, so we will apply nodal analysis. So this will be at higher potential. So this minus V minus 24 angle 0 degree upon 1 ohm. Then we have got plus V minus 0 divided by 2 plus 2j. Okay, so then we have plus V upon minus J equal to 0. So there is no incoming current. Okay. Now what we have got, we have to find I1 and I2. So once this node voltage we find out, then we can do V upon this resistance value and V upon this value. Okay. So we will get I1 and I2. Now solve it. This will, the magnitude of this one will be, so this V minus 24 angle 0 degree plus V. So 4 square is 8. So 8, and how do you calculate the angle? It is phi is equal to tan inverse of imaginary upon this one. So it will comes out to be phi is equal to tan inverse 1. So what is the tan inverse 1? It is angle 45 degree. So this will be root 8. Okay. So when you take out the root, 2 square plus 2 square, that is root 8. Okay. So for this one, it is V 1 angle plus 90 degree, which is equal to 0. Okay. So when you cross multiply, the value of V will come out to be, okay, so this value will be V is equal to 16.47 minus 31 degree. Okay. So this is the approximate value. Okay. So this value we know. Now we have found the value of V. So once we know the value of V, then we can substitute, or we can find out the value of I1. So how do you find? V minus 0, reference node, upon total ohmic value. So we know what is the value of V, that is 16.47 by 2 plus 2j. Okay, again calculate the magnitude. So this will comes out to be root 8 upon 45 degree. So this I1 value will be 5.82 minus 76 degrees. Similarly, when you calculate the value of I2, it is upon minus j. So minus j is nothing but 1 angle minus 90 degree. So when you solve this one also, plus 90 will go up. So it will comes out to be 16 minus 47 angle 90 minus 31. So it comes out to be 59 degrees. Okay. So this is in amperes and this is also in amperes. So basically these type of problems will not be asked in GATE because of the complexity in calculations. Okay. For this one we need scientific calculator. Okay. So this problem is taken only for the understanding of the concepts. Okay. So in the next lecture we will take few more problems based on AC analysis, then we will switch on to the resonance. Okay. Thank you.